Good day. We have dealt with solutions qualitatively. That's the trickier stuff of ionic equations and then qualitative analysis. And we have started the math of it looking at dilution. This booklet that you should have before you, and it should say solutions calculations and go through 4 types of questions, covers a lot of what we're up to, and then additionally we'll look at the last type of calculations you'll have to deal with. So this will probably take about 3 videos to go through. Door number 1, concentration of solute. This is something you should have been able to do from chapter 4 with the mole. We have 100 grams of sodium chloride. It's dissolved in 1500 mils of water. So simply put, you just got to take that 100 grams, convert it to moles, and make sure you divide by your volume in liters. So that's what we see here. Here's the conversion to moles, 1.71 moles, and 1500 mils is 1.500 liters, and we get 1.14 big M. So that should be absolutely simple. Door number 2, dilution stock solutions. We did a sheet on that, and so we remember N equals C times V, so number of moles equals concentration times volume. Volume has to be in liters. And in dilution questions, moles are conserved. That means the moles of solute you start with will equal the moles you finish with, and that's why we can say C1V1 equals C2V2. So, getting in the habit, you read the question. The main trick is to make sure you get the correct concentration with its appropriate volume. If you do that, the questions are a breeze. So I expect to see you itemize them like this. Then take the formula. C2 is the unknown. So I'm isolating the C2, so that means I have to divide everything by V2. Once I've rearranged, I plug in my numbers, and I get my answer, 0.0250 M. So hopefully that is painless. We've also, well, I guess we have another example of this. So in this case, we're going backwards. We're going back to a higher concentration solution. So we have this is a big volume, small concentration. We have a big concentration. That's a stock solution. So we're going to have a small volume. And again, rearrange your equation, plug in the numbers, and we get 0.00625 liters. That's fine. Or we can write it 6.25 mils. Now, dissociation concentration, we did some examples of that way back in chapter 4. So what you have to do is you have to write a dissociation equation and then use a bit of stoich. So we have 0.10 M, and this goes into solution. It's nitrate, totally soluble. So it's 0.10 M of Ag plus and 0.10 M of nitrate. In other words, the AgNO3 essentially has disappeared and become its ions. So there is how you deal with it. Now, stoich says 1 to 1 to 1 ratio, so next one we'll do something a little different. Now we have K3PO4. So we take our K3PO4 and we say, hey, 3K plus PO4 3 minus. And now stoich applies. So we have 3.4 times 3. Sig figs are 2, so we end up with 10 with a dot. 3.4 times 1 over 1 is 3.4. So those kind of questions should be very straightforward. So number 4 is where we're going to start the next video as we carry on with these notes. And these are not difficult. It's just there's a lot of steps, so it's easy to make a mistake, so you want to double check that you're doing things right. So that's the next video coming up.